Now, I can see from the results that it looks like the majority of you are saying you were good at maths throughout primary and secondary, and I've seen some people had said they were good in primary, but secondary kind of failed them. Now, that's really interesting. And I suppose my journey is that I suppose I wasn't always good at maths, and I feel like maths failed me a little bit. I went to school in the 90s where it was all about individualised instruction, and in Scotland we had SNP, I think it was, or SMP books, which were like the kind of smile card type situation where you just had to work through little books yourself. And I felt in these big mixed classes, and I felt like that really didn't work for me. And it wasn't until I got further up and took on higher mathematics, which is like A level in England, I found that I really kind of connected ideas together and eventually did do well, obviously. So, low attaining pupils. What do we often think about low attaining pupils? Well, a little bit of background. My career has been spent mostly working with low attaining pupils. For the majority of my career, I worked in schools in the Glasgow area, so inner city schools. And then I was head of maths for 5 years in a place called Paisley, where the makeup of that school was about 45% SIMD 1 to 3, which is our Scottish Index of Deprivation, which is the equivalent to pupil premium if you're in England. However, previous schools to that, I worked in schools where it was 93%. So I feel like this is this is just something I've had to deal with my entire career. So what do we think about low attaining pupils? Well, the first thing I think about low attaining pupils is that a class can be rebooted at any time, as it says there, if the teacher is sincere and ready for the long haul. And that very much describes what we have to do, and very much my lived experience and my experience of leading some others more recently who found it really challenging at the beginning, but managed to kind of change their own mindset towards these types of classes. So I suppose we have this question. Why do we have low attaining pupils? Now I'm going to pause for 30 seconds or so, and I just want you to fire on the chat any comments that you might have about that. So many thanks for all your comments there. They're coming up at a rapid rate, which is good. And basically scanning them, I can see lots of different issues in there. And there's obviously been a recent publication on low attaining pupils from Jeremy Hodgson and many other esteemed authors that have participated and contributed to that study, which is a really, really interesting read. It kind of worried me a little bit because I've been doing this presentation before I had the chance to read that study, but it was quite nice to see that they align quite well, and it aligns with my own lived experience, which is always nice when some research or experimentation comes together. And one of the things they've wrote in that paper is this here, that this idea of low attaining pupils is pretty much about delay. It's the fact that learning stopped at some point. It kind of lost its connections, it lost its place, and it's not really, they couldn't really find any evidence of these threshold concepts, although they do allude to certain things like related calculations, etc., that might have an impact on future progression, but generally they found it's characterized by delay. So why might that happen? Well, this is what we could see, and can I try and epitomize and exemplify of what the situation might be like for pupils. They go through mathematics and start learning mathematics formally when they enter primary school, and they have lots of ideas connected together. They have lots of these things all interconnected, but this one little idea is not fully grasped. it's not getting responded to, and it's not connected. And then over time, what happens is lots and lots of things become not grasped, not connected, not responded to. And I think this is what we see when we have kids, when they get further up and they get older and older, and they start to exhibit many of the things that you guys have put on the chat there, that they just have given up with mathematics. They can't do it anymore. There's no point in trying it. And it's just because they have so many things not connected in their minds. When they try and get a new piece of mathematics, it can't be assimilated and accommodated. And we'll talk more about that later. But let's imagine this scenario. So all of these kids, this mixture of kids, with all these kids that could have really well connected ideas and some that have some connectedness, but some don't have any at all, like very much like that last graphic there. If we try and separate them into what those bundles might look like, could you make that work every day, every single day? And I'm going to just launch another poll right now, and I'd appreciate if you could answer honestly on it. Can you track progress? Can you meet the needs and make interventions of every single pupil in that class? That's my question about people and thinking about mixed attainment. And really what we're trying to get at by grouping kids is not because we want to tell kids that, oh, you're not good enough to be in that class. That's not true. And often what is reported is that setting kids, particularly in secondary school, setting kids is going to be demotivating and blah, blah, blah. And honestly, in my lived experience, yes, that is the case, but a good teacher can turn that around in a matter of weeks, if not days. A good teacher can turn that around. And like we said at the very beginning, you can reboot a class at any time, provided the teacher is sincere and ready for the long haul and being very, very clear and honest with children. So what we're wanting to do is we want these kids to do the right mathematics. So when we talk about the right mathematics, we've kind of got three things that we need to branch out into. We need to talk about ability and attainment. So ability is this index of learning rate, and it's often conflated with attainment, and people talk about mixed ability classes. Well, ability can change depending on what you're learning, and very often people attribute low ability to low attainment, and that's simply not true. I've encountered many children in my career that are probably high ability but low prior attainment. I would even possibly put myself in the situation of low ability, high attainment. Think of the point of view, well, what is high attainment? I went to university and I became a teacher, so maybe that's classed as high attainment. Or at a school level, I got my good results when I needed it, but I was low ability because I feel like it took me a long time to learn a lot of the mathematics. I had to work hard at it. It didn't just come easy to me, where I had really solid prior attainment and as a foundation to build upon. So attainment is really like the snapshot of where people are in the learning of a discipline. And I'll just share those results with you there. Really, really interesting that every time I run this, the proportion of responses sit in that prior attainment category there. So, as I was saying, this idea of low ability and low attainment is simply not true. I've encountered, and when I talk about this presentation today, I will often reference this class that I inherited about 5 years ago when I started as head of maths in my previous school. In this class, I inherited them when they were in their third year of secondary, so what's that, year 9 down south, and they had been taught in what people would presume would be the best way to teach a class like this, and I'm going to get to what that people think about that in very shortly. And we had them grouped. And why should we then group kids? Well, in my opinion, I think for me especially, I don't think it's possible to teach kids where the attainment gap could potentially be 7 years in the one class. So how could you possibly meet the needs of every single child if you have that size of attainment gap in the one class? Now, I switched to mixed attainment for 2 years, and it felt right. It got off to a flying start and was great. Really well. Teachers liked it. As soon as we crept towards the end of the first academic session, I started having teachers come to my door and ask and say, I don't know how to teach this class anymore. I don't know what to do. How do I teach them? Do I pitch to the middle? And that's a seriously dodgy idea. Why would we pitch to the middle? Are we going to meet the needs of everyone? Or are we going to have all the kids who have the best prior attainment getting really challenged? I would say that it requires real expertise and proper training to become a mixed attainment teacher. So that's the other question you have. Do you have the capacity? Does your school or your department have the capacity? Now, people often think that they do mixed attainment teaching by having grouping within the class. That's not mixed attainment teaching. That's setting within the room. And if you want to teach true mixed attainment, then let's look at what that might look like and how we might manage that situation. And I'm sure you'll see that it's very, very challenging. So let's try and teach a mixed class. And I'm going to assume that you guys, all 750 of you, are my mixed attainment class. Okay, so we're going to try and do a little maths right now. Choose a 2-digit number. I'm going to pick 84. Swap the digits around. I get 48. Find the difference between the numbers. And I then want you to swap the digits of the answer and repeat the process. What do you notice about the answers? Does it always work, and why? Now I'm going to pause for a minute just to let you guys get familiar with that task and think about your responses and how far you can take this task. And then we'll come back to what this might look like in a mixed attainment class environment. Okay, so hopefully you're working your way through this. It's actually quite a nice task, and it's a task that I often use when we want to try and develop curiosity with particularly low attainers. This is a good task to use when you've got them grouped, because it really does develop curiosity and reasoning and thinking, and it's nice kind of easy entry, nice low entry, easy entry task that can be taken to quite a high ceiling, because we can get to a generalized form of it. So let's look at what might happen then. So what would we have? We would have 84 minus 48, then we would swap and do the difference again and again, and we arrive here, and we could put the 0 in there and then keep going and keep going. And we notice, obviously, that all our answers are multiples of 9. So let's take it to the general case, where we're going to say x and y are variables for the digits. And obviously, to make this, it's 84, so that's why it's 10, the tens column, and the units, and reverse it, so it would then be 10y plus x. Therefore, we find the difference, and we can see that when we find the difference, the difference is always going to be divisible by 9. Okay, really, really nice task. I really like it. It's a really great task to use. And there's a couple of questions on the Q&A there. Yes, you'll get the presentation slides sent out. Afterwards, probably early next week, you'll get an email with a link to a Dropbox folder that have all the presentations in it, and a link to probably all the recordings as well. The study, if you look up low attaining pupils year 9, Jeremy Hodgson, if you look, it's actually published by the Nuffield, I think, as well. So maybe on the Nuffield website, there'll be a link to it there on their homepage, but look up low attainers in year 9, Jeremy Hodgson, and you'll find it. So nice task, really good, but we've got a mixed attainment class. So we need a scoring grid, right? We need a scoring grid like this to try and figure out progression, who's learning, what they're learning, what are the next steps. So obviously kids would do various different things here. And I can see someone saying about factorising for low attainment. Obviously, kids wouldn't get there. So we have to try and figure out right? What have kids done? And kids might do something like this. So we might have kids that are just managing to get through one run of picking a 2-digit number. Some kids are specialising quite a bit to figure out, well, there's a connection with 9 here. And then we've got other children who might be able to work towards a general case. So what on earth, how on earth are we going to manage that situation? So this child here, what does this child do next? And at the same time, you've got to ensure that this child is still progressing with their learning and being challenged. So how can we possibly do that? And what people often confuse is they think that mastery learning is for mixed attainment teaching. It's absolutely not. It's absolutely not for mixed attainment teaching. We get homogenized groups and we make sure kids are doing the right mathematics. When kids are doing the right mathematics, then they can learn at pace. So by grouping them, we can provide more time to embed the concepts as they're introduced. We end up teaching topics less frequently, but for longer. So this idea of recapping, we're not trying to work at speed and tick things off. We're trying to make sure that we're teaching for understanding. And obviously, as I said a moment ago, pupils can work at pace. And honestly, I have seen this firsthand, that this definitely does happen, that kids can work at pace when they're doing the right mathematics, because they're doing mathematics just beyond what they already know. So what can we do then? Well, we have to try and diagnose what pupils know, looking at a range of methods and what we can do to figure out what they know. So that would be lots of quizzes and testing and maybe some nice tasks as well, like that swap away task that we were looking at. Maybe that would help us to try and determine what kids know, because we're trying to figure out, where is this gap? Where did the gap appear? What caused it? Where is the right starting point? And then we're going to develop a plan and try and develop a suitable plan, a suitable program of work to try and make sure that these kids are on some sort of flight path to maybe whatever qualification fits in your context. So we have to think very, very carefully about that plan and what that plan may be. There is the argument there is, can we just have this one curriculum that fits everyone? Maybe we can have one sort of curriculum or scheme of work planned out where pupils start at different points on it. Maybe that's something that we can do. And we'll look a little later about planning out something like that. So what are we going to do? We're going to quiz, we're going to analyze, we're going to group, we're going to plan. And the important part of all of this is review. So we want to review continually. We want to make sure we're trying to use as many kind of formative tasks as we possibly can to figure out what kids know, are kids on the right pathway, are kids doing the right kind of scheme of work, the right mathematics for them, and being very fluid and flexible with the changes that need to be made to make sure they are in the right place to do so. And Thomas Guskey talks about, when he talks about mastery learning, he talks about developing these units that we need to work on. And how he really talks about these units is, he says that a unit of work should be quite small, but not too small, because often people think about, oh, mastery is just like atomizing and getting really, really small things and checking them off. So it becomes really procedural. It's not about that at all. He talks about maybe a unit could be maybe a week-long sort of unit. So that amount of time you would take in a week for kids that are quite young, but kids that are maybe a little bit older, like getting to the end of primary school into secondary, you're probably looking at something up to 2 weeks long. So thinking about the content, and yeah, we do have to chunk it down a little bit, but we're not going to try and make it so reductionist that it's just a case of checking off procedures. So he talks about these 3 main things when we're trying to plan out this unit of work. And obviously you'll get the slides to read it later, but I think the quote kind of summarizes nicely one of the key points of why we would be doing this, that students are not then going to be guessing of what they need to do. It's going to be very, very clear what the learning goals are. And obviously on our Complete Maths platform, that all of that information is there for you. It's all there for you to use, so you can see it and the kids can see it also. So it's really, really important to plan units of work really, really well. But one thing we have to be mindful of when we're teaching low attaining kids is this here, that the plan will need to change. You will need to adapt, and always be willing to adapt when you start discovering pockets of knowledge. Kids know a lot of maths already. whether the lowest of low attainers, there is some math that they already know. And you'll find it quite interesting that as you try and make your way through a scheme of work, you will discover they have these pockets of knowledge. And what we need to do then is we need to adapt. So if we figure out that kids can actually do something, and we're quite happy to the level that they can do it, then we adapt the plan and we move in a different direction. Or if we discover there's some prerequisites that have not been properly sort of nailed down, then we need to add that to the plan. So it's really important that we use and try and gather as much intelligence as we possibly can to figure out what our pupils know. And what it's going to often feel like is this sort of graphic here, or graph that I've tried to describe for you. And what we think should happen is this kind of nice linear progress of pupils in terms of attitudes, work ethic, attainment. But very often it doesn't. And I like to call that the valley of despair, where you feel like, oh, this is not working for me. I should probably have stretched that out a little bit because it's probably a bigger valley of despair at times. But you probably get what I mean, that you'll have moments where you're just tearing your hair out with how difficult it is. But trust me, within one academic year, and I've seen this in the last 5 years when I was leading some staff through a process like this, you will definitely see some significant changes. Very, very, very significant changes within that one academic year in terms of attitude and work ethic. You might not see a huge bump in attainment within that one academic year, but you will definitely see it trending in the right direction. So a nice little quote there from one of these, I think it's one of these motivational books, but it really stuck with me about thinking long term. What is our long term goal? Is it just to try and find pathways and put sticking plasters over our curriculum and trying to just teach kids for the moment? It's certainly not. We want to build a system, a pedagogy of effect that's going to make it last and make it sustainable, a model that we can develop in our context that's going to work time and time again. So one thing we need to be mindful of is this little experiment from Newton in 1990, where he ran an experiment asking people to tap out a melody like Happy Birthday on a desk. And they were then asked how many of the people listening will be able to guess correctly what tune you're tapping out. And they reckoned, obviously, as you can see there, 50%, and you can see it was actually way, way less than 10%. And this is where we have to be careful as maths teachers. We have to be careful of what is it like to be a novice? What is it like to be at the beginning again? Because often we only remember the end point of learning a concept. We don't remember so much the building blocks or the steps it took to get there. So we might try and introduce something like, I don't know, something like trigonometry. And we're going to give them all the kind of richness of the background information and connections to the mathematical ideas. And we have a sense of ease about this new idea, but it sometimes leads it to being communicated to the pupils as though they were like mini experts. So we have to be very, very careful about that. And often why it's quite nice, and what I found worked really well, was trying to group teachers together that had similar type classes, similar type groups, to try and work together quite closely on even their instruction and how they would even vocalize that instruction and talk to each other about the examples and how they were going to explain it, the models they were going to use. So novices versus expert is quite an interesting area. And the way in which they're different is that novices tend to try and figure out what kind of problem it is. They're really racking their brains for prior knowledge. They're trying to associate it with other things, particularly the words. They focus in on the actual words itself and don't have many links. They're looking for landmarks. They're looking to try and classify it into all these problems that they've worked on. And very much that little statement at the top there, what you know determines what you see. So if fundamental knowledge is not in place, then it's going to be an absolute disaster. And I think Colin Foster puts this quite well about if the level of reasoning and problem solving is really, really high, then the level of mathematics needs to be fairly low to not induce far too much kind of maths anxiety, and you end up getting this kind of flight or freeze response from pupils, particularly low attaining pupils, who've had a really probably quite a bad experience of mathematics and probably don't have much support at home as well. It's very unfortunate that most low attainers come from some of the most disadvantaged backgrounds. Experts like us, and how I can best describe this situation is when we see like a past paper question and kids are stuck on it and they ask you for help, almost immediately we can see the strategy. It pops out to us because we've already have all this prior knowledge, and that prior knowledge is just it's not only quantitative, it's qualitative as well. So the knowledge is organized differently. So we kind of work forwards with problems where pupils try and work backwards with problems. And it's just interesting to put yourself in their shoes. And a really nice quote from Daniel Willingham about this idea that people will avoid thinking. So we're naturally curious. And Stuart, in his first session, talked about that idea of biologically primary. That's just something that's innate and built within us. Like learning to talk and learning to walk doesn't require a huge amount of effort for children, but learning to read and write requires a massive amount of effort. So this idea that that secondary knowledge is kind of domain specific and people will avoid thinking at all costs, generally, especially low attainers. So what does this mean then? It means these three things here, essentially. And I've got some other information at the side that you can read at your leisure, but I've alluded to this already, that pupils are not empty barrels. They're not small experts, so we can't treat them the same. And I can see Kevin's put on the chat there about the curse of knowledge. That's really important, like the tapping experiment. And our teaching should take account of this, you know, and it's really important to try and work on metacognition as well. Really important to try and work on that throughout, and offering some tasks that involve that is really important. And one way to try and describe how children assimilate and accommodate knowledge, like Piaget worked on all those years ago, and he kind of talks about the idea of children, young children know about dogs. And maybe they go to the park one day and they see a Great Dane or they see a Chihuahua. And now they've got two new pieces of information that need to be classified into the child's existing dog schemata. So they maybe have to think about, well, now I know that there are big dogs and small dogs. So now they know that this big dog that they remember from the park, that's big dogs, that goes into that category. That really small, tiny dog, that goes into that category. And that is how they accommodate that information. So this leads me quite nicely on to motivation and achievement. And I'm going to run just another quick poll to let you see, to get some responses from you, to see what you think about it. And there's some really interesting information about motivation achievement, and the two that I've picked out for you today are these two here, and that really does strike a chord. 20,000 pupils in Britain each year give up on going to school by the age 14. Now, isn't that just incredible? 10% of pupils report that they hate school. I would be interested to see the numbers for maths. I would be really, really interested to see that. But what's interesting is that from Hodgson's report on low attaining pupils, they get very positive feedback about maths teachers working with low attaining pupils. To get really good feedback about, they really like their teachers, they feel their teachers really support them really well, and that's wonderful, isn't it? Really wonderful to see. So should we try and motivate first by engagement, through engagement? Well, I don't think so, and it looks like I'm probably going to disagree with a lot of you on the poll there. I'm just going to end that and share the results very quickly, let you see that. So 67% of you agree that low attaining pupils are best provided with experiences of real life and use maths relevant to real life. I disagree. I think that we have to promote and build motivation through achievement and success. So I'm not saying we should never contextualize, but you have to be careful with contextualization because it sometimes can pigeonhole that piece of maths to the context. So we have to motivate and build intrinsic motivation through success in the class, and that's particularly important with low attaining pupils and my lived experience of it. Those kind of moments of in class and really offering sincere praise when it is actually when it's actually needed. You know, there's this kind of thought about what's immediately rewarded is repeated. So when you're seeing kids doing some really good work, really hard work, they're working hard, they're thinking hard, then you're finding every opportunity to reward that and praise it and really build those hugely positive relationships and rapport with pupils, because that's going to make a huge difference. And you can see some nice quotes that come up at the bottom there from Benjamin Bloom. This idea, it changes a person's view of himself or their self. Really, really does really change the way they think about things. And we know that mindsets are really important. PISA has told us this, and that mindsets for kids that are in these disadvantaged backgrounds, if they really have a well-calibrated mindset, so this is not growth mindset, this is not like, I can't do it yet and putting posters up. This is building this mindset in your classroom. Really trying to develop and work hard at that positivity and really having an ethos of successful learning. And that's what we work on when we work on mastery learning. And as I've said at the bottom there, sincerity is crucial, and dishonest praise can be destructive. So this mediocrity, you know, is not going to work. It's going to work in the moment. It's not really going to do anything. It could be quite harmful, really quite harmful. And we can see that these mindsets can actually overtake home environment and student behaviour. And that paper that I've been talking about, it was really nice to see that they had that mentioned in there as well. So what we're going to do is we're going to take a little look at some evidence of mastery learning. And this piece of work is a huge piece of work from '95 from Brian Whiting. And he worked with its business studies, albeit it's not mathematics, but you can easily extrapolate what was said in this study. And I think that's quite important, that quote at the bottom. But let's look at some of the information. Let's look at some of this information down here that, and what came out of this study. So first of all, some of the survey of perceived learning, we can see what the students felt about when they're being taught in this way. And the one that sticks out to me is this one at the bottom. 97% felt their knowledge of and success with mastery learning positively affected their learning in other classes. And some of the quotes that came from the students is just incredible. You know, really, really, really incredible. It's easier to learn. It's the first day I've ever received. I don't have to guess what to study. And it's just incredible. Like, I think that I've seen this firsthand, really have seen this firsthand. It does work. And if you look at the time, people always say, oh, mastery learning takes too much time. You have to spend a really long time at the beginning trying to tidy things up. Well, yeah, you do. You do have to spend probably up to about 20% more time. But look at the time and how the time reduces as you move on. And let's even look at pupils retaking assessments, because it's really important to have these assessments and parallel assessments in a mastery learning model. So look at this down here in terms of year 2, we get to unit 20. Very, very few pupils retaking tests. Off-task behaviour from Kathleen Fitzpatrick in '85 done a study on purely on corrective teaching, and they discovered the observers sat there with stopwatches and basically looked at any time that the kind of majority of kids were off task, and they stopped it and then started again. So really looking at trying to maximise uptime. And what we can see here is that when they were trained on this correctives and mastery learning process, we can see there's a massive, massive drop in off-task behaviour. And they talk about, there's a number of factors there. One of them being the pupils actually began to understand the learning process better, you know, when they were working with this model. And one of the really nice things that you can do with your class, because one of the things we forget about is it's not just about the individual. If we get them grouped, then we can build, just to pick up on that point from Kat there, that teaching for mastery is not about mixed ability. Absolutely not about mixed ability. Mastery learning, if you read the true mastery learning, is from Benjamin Bloom in that era. So I would encourage you to have a look at that. It's definitely not about mixed attainment teaching. So what we can do is we can develop this motivation, we can develop this success, this ethos of successful learning, and this serves many purposes. One, for the teacher to see that you can see this iterating towards something where the gaps are not too big between the first assessment and the parallel assessment. It motivates the class to work together and almost develop that team that we're thinking about, and trying to build them together and work together and help each other on the journey. And that's important, you know, really important. Kids love that. They love being able to work together and think about it over a team, and we're going to get through this. And that all comes from the kind of sincerity of the teacher. It's really, really important to try and model this for the class and not for individuals, because then obviously, as you would probably imagine, kids can kind of switch off and not be interested in it, or become embarrassed about doing well or being the best. So it really got me thinking about where else do we normally see this. And I normally hate these cheesy images, but I'm going to just give you one. And in the military always have training exercises that the individual has to complete, but they also always have training and obstacle type exercises where it cannot be completed unless the team works together. And it very much describes for me what I'm trying to do when I'm working with low attainers. This is my objective. And we know that the importance of the teacher in that situation as well. We know the importance of the job that we do and the job that you guys will be doing right now, and what you can do in terms of creating that climate in your classroom. And that's really, 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 really important. So what are we trying to work towards then? Well, we're trying to work towards some sort of model like this. This is what we're trying to do in this mastery learning model. We're trying to develop this culture of successful learning, where we're learning some sort of unit one, whichever way we've developed this unit of mathematics in our scheme of work, our curriculum, and we offer some assessment. We do corrective teaching, and in that correctives process, let me just jump and show you what that might look like and how we describe it. That it's really important that we offer as much feedback as we possibly can, and that can come from simply just the teacher, or it come from instant results or whatever through a kind of diagnostic. But this feedback is best being is kind of diagnostic and prescriptive. So it reinforces precisely what students are expected to learn, identifies what they've learned well, and describes what needs to be learned better. Correctives are, we're obviously trying to remedy problems. We're trying to fix the problems in the moment, rather than it going on and gaps getting wider. Pretty self-explanatory in how we do it. But what we don't want to happen is, we do not want, when we're trying to do correctives, to almost like have a Robin Hood approach to the classroom, where we're going to rob time from the academically rich to give to the academically poor. Now, I know that sounds terrible. So what we want to do is, we want to make sure the kids that don't need correctives, the kids that have got it first time, have proper enrichment materials to do. And it almost becomes like this reward for successful learning. And that's how you develop this ethos of successful learning. You start small, you know, your units are small, so you can work on something that's going to be really achievable for the kids. And if they're doing the right mathematics, this will work. So as I was saying, as we move on and we look for, I've said 80 to 90, I'd be looking for 90 or above of the class attaining mastery. You know, getting 80 to 90% of those children getting 80% or above in these little assessments that they offer, and making sure we're doing that corrective teaching as quickly as we possibly can. And as we move on, we can see that maintains. And if we get to some arbitrary unit 10, we can see we're still there. We're still attaining mastery. Now, obviously, this unit, if things are sequenced properly, will have much of the prerequisites for unit 2 or unit 3 in it, possibly. So we have to make sure that we spend a little bit extra time here making sure this is nailed down. And if it is, then you find that things start to speed up. So good question from Richard there. How long does mastery take? I have no idea, Richard. It takes as long as it needs to take, depending on the kids you've got in front of you. So explicit instruction is really important. And one of the big things that came out of the recent report on it, and often overlooked because people conflate what it means. And when we talk about explicit instruction, we are not talking about just that transmissive or transmission teaching where it's just lecturing and just giving examples at the board. We're talking about being quite interactive with the pupils, but it's being directed by us. So we're trying to blend that with some inquiry-based stuff as well. And we know that kind of a nice way to think about it would possibly be 80% of it is quite teacher-directed and 20% is maybe offering opportunities to behave mathematically. But that depends on who you've got in front of you. It really does depend on your context and who you've got sitting in your classroom. So we know that example problem pairs are a phenomenal tool in the classroom, particularly for low attainers at that point of acquiring new knowledge. We know they're a great tool. And what's interesting about this research is that we can see that problems only, the red one, actually kind of looks as if it achieves the same goal as alternating examples and problems. So example problem pairs. Examples only, yeah, they kind of work initially, but they kind of die off a little bit. But what's interesting is this: the conceptual knowledge game for alternating examples and problems is far bigger than any other approach. And that is what we are wanting. That is what we are aiming for. We're trying to really develop that conceptual knowledge gain and far transfer. So example problem pairs are great. So let's look at how we might do one. Okay, here we go. -5 minus -4. So I'm going to write it properly with the superscripts to distinguish between the minus symbol and the negative symbol. I recognize here that I'm going to use the additive inverse. So I add and make this the opposite of, the inverse of, the additive inverse of -4. And then I can look for 0 pairs. And I've got -1. And that's how I'm going to go through it with the kids. Obviously very rapid right now with you guys because you're experts. And then I'm going to say, okay, go ahead and try one. And the problem with that is that generally we have this. Kids have forgotten the sequence. They've forgotten what happened. So what did the teacher do again then? Why did we make that +4? How did I end up with negative, just one red tile? What that seems to be a bit of I don't know what I'm doing here. Like I can lay down the tiles and I'm a bit confused. And then this is what happens in a low attaining environment. They can become quite dependent on you. They can become quite mortgaged to you. And that's fine, but we need to build independence so we don't have helpless hand raisers that just get stuck at every step. We need to try and build that independence into their practice as a pupil. So what we're going to do is we're going to offer them a little kind of visual instructional plan. So here we go. I'm going to organize the tiles and I'm going to decide what am I going to do next. My next plan is I am going to use additive inverse. Okay, so I'm going to use additive inverse. And every time I move to a step, I like to go back to the beginning. Depending on your style of pedagogy, then maybe you would do it in chorus with the class or whatever way you want to do it. So I've got additive inverse. Right, so what's next then? Well, we can look for 0 pairs. So let's start again. I'm going to organize my tiles. I notice that I've got subtraction to deal with. So I use the additive inverse. And now I can align up my 0 pairs. What's next? Well, they are all equal to 0. So I'm left with -1. So let's check that again. I organize. I've got subtraction. I am going to use the additive inverse. So this becomes the opposite of -4. And now I'm going to be able to kind of align up my 0 pairs. That is all 0. So really, I'm left with -1 as my answer. And we're just offering this visual plan. So when kids are doing the one on their own, and I could easily just split the screen across the way or have this on the board and write their example on a whiteboard, whatever logistical way you need to do it, you can then point them in the direction of this and say, right, well, look at the plan there. How do we work through it? How are we going to get from step to step at that initial point of learning to work with subtraction of direct number? We could do it again. We could do it for addition. So if you were to do addition right now, where would step 3 be? So think about laying that as a column addition. Where would step 3 be? And then you're going to try and get kids to do some. So we could work in the same way. What am I going to do? Right, I'm going to add the 9 and the 6, and I put down 5, and I'm going to then carry 1. You know, and then work your way through it again and build it up step by step to show the trace of the mathematics. You know, this is the trace of the mathematics. And hopefully, if you do this in the beginning and get kids used to being independent on this, you'll start to need it less and less. You know, I probably wouldn't recommend doing this with quite high attaining kids. It depends. It's worth a try. This for me really worked with low attainers, and it's very kind of building up the steps to ensure that they know what step corresponds to what when we're doing addition. And I've got division here as well, and you can see how we would work through that. And I've left this one open at the end to finish it off. So really just showing all of these steps and how this would work, so that we don't have kids just depending on us all the time to go and help them. It then frees you up and makes you mobile again to really get in amongst the kids and get in between those desks and talk to them, prompt them, ask them questions, really get to the heart of their understanding, trying to get inside their heads and understand what they understand. And then we're at the point of, and sorry, one other thing about working with example problem pairs, I could do an area model for this type of question. 3 groups of x+3, got my answer, right guys, do your own. But what you often find is that we have kids that work at different paces, like even just writing speed. So kids would do that in a flash because they'll get it, because I'm really breaking this down quite a bit right now. And they're going to be sitting doing nothing. Do I want them sitting doing nothing? Absolutely not. I want to maximize uptime and minimize off-task behavior. So I'm always going to offer that. Can you make another? I'm going to drip feed the opportunity right now to make sure they're starting to think of undoing at this point. So, and then I would obviously model the solution. And then I'm at the point of I want to give them some questions to do. So it's a really lovely piece of research from Rohr and Taylor, and Doug Rohr in particular. So that author there, Doug Rohr, if you look up his website or just Google Doug Rohr publications, then you can go and look at, he's got some fantastic stuff. It's all about mathematics learning, which is great. And in this experiment, it was experiment 2 in this paper, he's trying to investigate about overlearning. And what they done was they taught some university students about permutations who hadn't really studied that in the mathematics they'd learned at school level. And what he then discovered was that they gave the kids, gave the students, they taught them by example, and they gave them some questions to do, and that was fine. They sent them away, gave them a test after 1 week and a test after 4 weeks. There was 2 groups though. One group were given 9 questions, and this group were given 3 questions to do when they were taught initially about the concept. So what we can see is that it actually made minimal difference to how many questions they'd done on this very, very, very specific thing that's going on. So that they didn't have to do that many questions to overlearn it. In fact, they worked out that you actually only need to do 2 questions to overlearn a very, very specific thing in maths. However, they do say mathematics educators need to err on the side of caution. So what I found quite staggering was though that after only 1 week, look at the accuracy drop. And in that initial point of being taught and doing the 3 questions, 9 questions, etc., they observed an average of 94% accuracy. Look how much it's dropped after 1 week. So we know that we need to do more. We know that just doing procedural and routine questions is not enough. We need to do more than that. And how I tried to frame it was, I tried to just put it together like this. So some procedural that I want every child to do, and I'm going to offer them some deeper thinking tasks, non-examples, etc. And trying to really get them thinking and working hard in class and not just saying, right, you've done that 5, there's another 5 of the same. So I think it's important that we have to offer opportunities to start thinking a little deeper, undoing and looking at non-examples. What's went wrong? Can you correct it? Really, really important. So let's move on and let's take a look at some other things to do with time and time in the class. And very much in the class and the way I worked was, and I've mentioned this kind of already, but this idea of uptime and off-task behaviour was I was given lots of praise for kids that were working really, really hard. What we have to look at is this information here about uptime and the amount of time allocated to things in the classroom. So what we can see here is that this is a big kind of government study on average and high performance schools. And the thing that sticks out the most is this starter here. This idea of a non-gain starter. And I think it's really interesting that high performance schools just don't do them because they deem it as a complete waste of time. And I think that, yeah, there's a caveat to that. If you need it for logistical reasons, like you're moving rooms or whatever and stuff like that, then fine, yeah, go ahead and do it. But you need to think, is it worthwhile? If you're giving it for retrieval practice, often people say that to me, then are you marking every single piece of work that's getting done? So every pupil's piece of work, are you giving them feedback on that? Because then how do they know that they're doing it right or wrong? I know you can put the answers up and stuff like that, you can do it themselves, but you have to really think about, is it the best use of time? Could I not just start from where I left off? You know, or could I do some bridging, which is quite an interesting idea as well. And we look at how that adds up. It's an additional 480 hours of mathematics teaching. Isn't that incredible that that all those kind of 12 minutes add up and add up and add up? And I think it's really interesting to think that your next time you're in your class, whenever that may be, is to really think about how much the kids are doing mathematically, thinking mathematically, working mathematically. Is there any downtime? Why is there downtime? Should there be any downtime? Should never be seeing pencils down. It should be a case of they should be thinking, working all the time to maximise the amount of time we have with them. So one thing with low attainers, patience is key. And we want to get to some problems where they have to think quite hard, really, really think hard. But we have to follow the kind of Goldilocks degree of challenge. Not too hard, not too easy, but just right. So how might that look then? Well, I think there's a nice quote here from Engelman, who's obviously attributed to direct instruction, and very much you would not expect him to make a quote like this, but I think when he talks about this idea about the routine and then testing to see if the routine works, we're providing them with a framework for discovery or a framework for curiosity. And really we have to start small when we're trying to build up these kind of problem solving, reasoning, mathematical thinking skills. Now here's a task that's a wonderful task that Richard Perring shared on Twitter a few months ago. It's a fantastic task. However, this would not be right immediately with a class who are not used to working that way. Okay, so what do we need to do then? We have to build the culture. So let's look at this question here. Fine, it's a question. It's an addition question. Kids can answer it. Could understanding be superficial though? So we have to probe a little deeper. We have to try and connect this and try and build some surface structure on the problem. So maybe we could use a kind of open middle style task, but constrain it still. So all kids could access that are ready for this mathematics, that are doing 2-digit addition. They could access this. And now they're going to have the opportunity to think a little freer and think and work and try and reason with the problem. And then we really take the shackles off and just give them kind of one constraint or two constraints there. Make the largest sum using only 1 to 9. I think like that is a really, really good way to think about this progression. And then we're going to work towards something like this at the end. But we cannot just jump in immediately and work towards something like that. We have to just build and develop this culture with low attainers, because that's where we want to be. We want to be at this point where we can do really wonderful tasks like this to get some great insight out of it on our own, for our own benefit and for the kids as well. So I like to try and put it all together. Now you see my previous slide now I put it together. This is how it kind of culminated for me. I still had some procedural stuff going on, but I wanted to offer some deeper thinking tasks, something that was a bit more purposeful and still gave them lots of practice, but they had to really think about it. And then down here, they're really having to think a lot deeper about what's going on, a lot deeper about the mathematics and the kind of structure and the concepts and the underlying principles of what's going on. I think that's really, really important that we do that in the mathematics classroom. And I found this really worked for me. I kind of had it on the screen, giving me these two opportunities here to make me mobile again, so kids, when they're finished this, could mark it. It was fine, great. You can now go on and think a little deeper, rather than me just pulling out a book or a sheet and saying, right, okay, go and do more of the same. They're not really going to get a lot from that. I'm pretty happy with the fact that if they've got all of these correct first time around, then I'm pretty happy that they've overlearned it. They know what they're doing. They can now go on and think a little deeper. So I'm trying to get as much mathematical thinking into the period as possible. So we're almost there. And Robert Kaplinski, as you can see at the bottom here, his problem-solving framework, he offers a nice little way of thinking about this and tries to get kids to really put down in paper what they're thinking. So really working on metacognition and getting them to think about, right, what am I trying to do? And this is obviously for a particular problem about trying to figure out a number and placing an estimate on there, and really getting them to articulate what they're thinking to develop this, that it then just becomes internal, which I think is a really quite a nice way to do it, and a nice idea that you can just go ahead and make something like that yourself to suit your context, or just use it. My last kind of question that I want to ask today is, what do we think about this here? What do we think? Procedures or conceptual? What should come first? It's quite a common question to ask, and I've launched that poll, so you can go and have a little play with that and see what you think. And if you want to comment, then feel free. I know it's hard to keep up with the chat with this many people, but it'd be interesting to see what you guys think about it. Where this kind of debate in my head came about was, I needed kids to do this. I needed them to do 4%, things like that, things that maybe you would offer low attainers a calculator to. And this came from the fact that I didn't have any calculators and they didn't have any either. So I thought, well, what's the best way to go about this? I want to connect it to the different representations of percentages and what they mean. So I want to do that. And I don't have any calculators, so what's the best way? So I decided to do this. I thought, right, well, 4% is 4 over 100. And I know I could simplify that, but actually I know that that means 4 divided by 100, which is the same as 0.04. And the question saying 4% of 67, and we've already discussed the fact that 4% of 67 could be 4% multiplied by 67 in a sense. So I could write that down. That means the exact same thing, 4% of 67. And then I'm going to say, well, let's look at using Napier's bones or the lattice and compiling this together. And I'm going to work out all my answers inside, and then I'm going to collect by place value. So all you're really doing is collecting by these powers of 10 diagonally and thinking about the question, decimal places that are in the question. Okay, I've got 2, none there, so I'm going to have 2 in my answer, and I get that. Very procedural, very mechanical, debatable whether that would be a good approach. But what it led me to think was, it led me to think that I had an opportunity here. I had an opportunity now to basically give them questions that allowed them to see that their method was inefficient. So I then offered these questions here, and they started to try and do it this way, and they seen lots and lots of zeros appearing and thinking, this seems like a bit of a waste of time. I don't think this is the best method, so how else could we do it? And try to build in them discovering that this is not an efficient method. It's a bit like a kind of manual calculator. So what's a better way? And to really cement that idea and bring it home, I gave them this task. And this is a nice task from Colin Foster. This task serves a lot of purposes. It really helped the kids see that that first method was not efficient and helped them understand the structure of it a little bit. But it did give them the opportunity to do lots and lots of purposeful practice. Really wonderful task. I would encourage you to throw that at your kids and see how they go on with it, and really try to bring out the fact that there's better ways of doing this. So in summary, I've got these 3 things that come to mind when I think about low attainers. Setting that expectation high, that kind of high praise for hard graft. You'll definitely be surprised at the results, and kids are great at living up to their expectations. It might take a little bit of time, but remember, we're in for the long haul. So hopefully you have found that useful today. If you want to get in touch on Twitter, I can continue the discussion there. So thanks for joining me today, and thanks for coming along to the conference. And again, thanks to AQA for sponsoring this event.